Oh, my name is Hrishi, and welcome to this month's updates on Nova CVS and Nova. As a part of this channel, I'm going to create monthly videos to update on the progress that we're making on Nova CVS. If you're new here, please like and subscribe to the channel so you get to see the work we're doing with OpenMC and other open source projects with the context of Nova CVS, which is a tool for licensing support and regulatory support for nuclear power plants. Just to sort of give a background to people who are new, there is a white paper that you can download. I'll put a link in the description below, which talks about why this tool was built and what the problem is. Essentially, we are trying to solve the site licensing problem as far as the deployment of new nuclear power plants is concerned. Now, essentially, this is traditionally been a consultant's job where it takes a lot of time and a lot of effort to figure out the physics and the site and the regulations. So in this sort of document, we talk about how this is really done in silos, the neutronics, the plant, the site, and the regulations. And we'll cover all aspects of this. But essentially, this is a job of a regulatory engineer within companies, and they have to bridge this gap and link them somehow. The physics, the site, the plant itself, and the regulatory sort of architecture that is on the site. So we are building this link. And to use this, we are using a bunch of different tools to join them. For the neutronics, we use what is known as OpenMC, which is a open source library to simulate some of the neutron transport and flux and so on. For the plant, we are building a brand new open source digital twin library, which simulates the plant itself. It's called ProcessForge, and I'm going to talk to you a little bit about that in this video. And then we have the site itself, about where the plant could go, and the regulations, the safety regulations associated with this site. And the idea is that you can link them and demonstrate compliance with the goal to reduce the time for licensing and streamlining by building these, let's say, modern tools with it. So let's begin. I am in my user interface, so you can go to the website urjanova.com and then start here. The white paper is here. It talks about how you use the API and so on, but let's go take a look at the client. I'm going to select the workspace. If you remember in my last video, I talked about creating a user interface for OpenMC. So this month, there have been a bunch of updates. So obviously I select the workspace, but what you're going to see essentially is a user interface, let's say companion for OpenMC. If you're familiar with OpenMC or any of the neutron transport codes, basically they are either Jupyter notebooks or Python scripts or things that are, let's say, a little bit technical. But when it comes to regulation and so on, we need auditability and sort of demonstrate that to somebody else who is not an expert how this works. So for that, essentially, we have built some user interface for OpenMC. So in this use, I'm going to use the OpenMSRE GitHub repository. So if you're familiar with it, it's a open source Python notebook that implements the molten salt reactor, let's say, simulations. Look at the last video in last month where I introduced how this was created. But the idea, what you're seeing here, is basically a user interface for those simulations. Here you can see OpenMC settings. In this case, we have, let's say, a low fidelity setting and a high fidelity setting. So this month we have a little bit better user interface. Obviously, you can compare between these two settings and so on. In the same way, you have materials and material mixes. So you have basically all the materials from the MSRE experiment. You can do version compare and so on. So now we have these nice cards, as you can see, a very visual way to show what materials are there. Obviously, now the theming support has also been updated. If you are into that. And basically what we did this month was to improve the user interface for some of this. Now, some of this is obviously under heavy development, so this will change. And if you have any strong opinions on this, please just feel free to reach out in the form in the description below. Now, the other thing that was done in the last, let's say, between last time and this time is essentially this kind of what we call as OpenMC visualizer. So once we have some simulations, obviously in OpenMC, the simulations are written as H5M files. And here what you are seeing is the ability to basically compare two different types of simulations. So I can see here, for example, the simulation 1 and simulation 2. Obviously, when you do a high fidelity and a low fidelity simulation, you can use Python tools, but here you are using the results, overlaying it on a geometry, and all of this is managed for you. The reason for doing all of this will be apparent soon, but what you're really seeing is this kind of a visualization of, for example, what the data is in the state point file. So here you see, for example, we have two files, the high fidelity simulation and the low fidelity simulations, and we can basically make a comparison or a diff between two different types of simulation ones. And because this is all stored in the database and sort of there, you can then do all kinds of reports and analytics and have traceability and so on with it, which is obviously a very important part from a regulatory point of view. Essentially, the idea is that you provide a reporting mechanism and a user interface to manage some of these, especially to people who are not from a neutronics background. As I said to you, we are going higher and higher in the chain. So this is OpenMC, part of it. Then we have the digital twin. Then we have the site, and then the regulations and so on. So we are at the geometry and the OpenMC part. You can see here this month the user interface has been refreshed and a little bit, let's say, more user friendly. These will evolve, as I said. If you look at the video last month, the interface looks slightly different. Okay, so that's the new stuff in the OpenMC part. As I said, this will evolve. We also wanted to show you very quickly, for example, the geo boundaries. So essentially now we are at the site part. I'll get to the plants very shortly, but basically we are at the site. So we are linking neutronics to the twin and to the site. So here you can, as you can expect, some location, potential location where you're trying to put this plant. You have, for example, details about the wind patterns, the meteorology, and so on. And then you can also have this a 3D map with the site visualizer, which with the exclusion zones and the boundary zones that are part of the regulation. So as I said to you, we are sort of going one step above because the regulations talk about the site and the site safety and so on. And so in this case, it is that. Then you can sort of, because we have all the neutronics information and the, let's say, the weather information, we can do some very basic safety analysis. I'll get into all the details of this in the subsequent videos, but the idea here is that you can then develop heat maps. And obviously, because this is done in the database in a unified tool, you can then write reports, develop, let's say, safety cases for the specific requirements which you will get to. And for each of these, we will have dedicated sessions for it. So as you can see here, there's a way to store the boundaries and the meteorology of the site so that we can then do what-if scenarios and develop like a ban for it. What I also wanted to talk to you today about was the flow sheets. For example, this is a project that we are working on. It is called ProcessForge. This is, you can go to github.com or Genova ProcessForge. And so basically this is a digital twin a platform where you basically define the plant, the pipes, the valves, the sort of the components of your plant, the heat exchanger, and so on. And then this does some of the transport associated with it. Now, what is interesting is that obviously we are not inventing new new transport or fluid dynamic, let's say, libraries. We are using existing open source ones. For example, you can see here with the Cassidy and these other libraries, and you can sort of take a look at the repository to do that. But the idea is that you build a flow sheet, you validate the flow sheet, and then you run the simulation based on essentially steady state and dynamic simulations. And then there are ways to export the data. So if you look at, for example, in the ProcessForge changelog, here you will see all the things that have been sort of added in March. You can see, for example, there is a validation repository that you can sort of use independently and to validate the results. And then it has all the modern things that you could expect, which is a ZAR file output, which is much easier to process on S3 and so on. Then you have the FMU export capability, so you can then use it with other tools. And also some other interesting things that links some of these things. So let's just take a look at how ProcessForge looks. We can plan to talk about ProcessForge in a very detailed way in the coming videos. But basically, this is the closed loop chain, for example. Here you have some materials. In this case, it's just a simple benzene toluene mix, and then some pipes made of steel. And then I have the units, tanks, and pipes, and so on. So I can create this simple cycle, and so that you can sort of see, let's say over here. So you have that JSON output there, but you have a visual, let's say, interface. And this is linked to, for example, the materials and so on. And then you can also, let's say, run the simulation. So you run that flow sheet using ProcessForge. As I said to you, ProcessForge is meant to be open source and pluggable sort of a digital twin, so that you can run it with any tools that you have. But here you can see, for example, some of the thermodynamics and the properties, for example, of the feed and the stream. In addition, you can see the logs and so on. So all of this is obviously fully open source, and all the user interface is doing is just ensuring that these are run and linked up together. Again, the goal of this is to essentially link different silos together, okay? Normally, these are totally independent, let's say, things, and any safety analysis, any design, let's say, basis has to navigate all of this up and down. And the point of Nova CVS is to provide a modern interface that links all of this. And because we have the neutronics, the twin, and the site, and of course we'll come to our regulations shortly, we can then sort of develop documentation for some of the use case. At the moment, basically, we are focused on site safety and development of the site, but you can imagine expanding this to these other, let's say, more interesting, let's say, a bit more comprehensive safety case, and the goal being to speed up the licensing activities, because at the moment it's mainly done by lawyers and consultants, and it takes a long time and a lot of effort, and in many cases the traceability can be very problematic. So the goal of this is to ensure that there is a, let's say, fully vertical chain between them. So as I said, this is a very long-term project, using some existing open source tools, building very ambitious new things like ProcessForge, and also obviously much more established things like GIS and the regulations as they evolve. And so the idea is that you essentially build a CLI eventually, where you can say, for my safety case, here's the tally, here's the site, here's the regulation, build the documentation for it. Obviously, this is a little bit, let's say, in the future, but the idea is to start linking them at a step-by-step basis. So this is the latest updates for the month of March. If you have any questions or thoughts, please feel free to drop a line. There is a contact link below. And if you want to hear something specifically, maybe more about ProcessForge, more about how the user interface is managed, what are the benefits of this type of user interface in sort of the comprehension and understanding, I'm very happy to just make more videos about this. And as I said, if you are specifically interested in ProcessForge and there is a changelog, you can follow them and follow it on GitHub. And that's it for this month. We are in very sort of heavy development, so we will come back to you at the end of next month with another update. And in the meantime, if there's anything, just please let me know in the comments. And make sure if any of this is interesting to yourself or some of your colleagues, please feel free to share it. And I would love to talk to them about what they're building. Thank you very much. See you in the next one.